KVM security groups.
Yes, okay. So last year at the CloudStack Conference, I gave a talk about Cloud Init. And Giles said to me, you're going to give a talk about Cloud Init? How boring is that? Because I wanted to tell something how Cloud Init worked under the hood, how it actually worked within CloudStack, so your SSH key magically gets into your virtual machine. That was my talk of last year. And talking about security groups under the hood inside KVM, does anybody ever care how they work? Somebody just calls an API, right? Open a port on a virtual machine and then it magically works. Now I'm going to be talking about KVM security groups, how they work with KVM. So a bit about me. The Netherlands, I work for Your Online as the CTO of the group, so I used to do a lot of development for CloudStack. I haven't been writing code for a couple of years, but we use CloudStack a lot within our group. In Spain and the Netherlands, we have 2 big cloud deployments, and I'm pushing to get more CloudStack within our companies within Europe, but it takes time, So, but I call myself an open source enthusiast with CloudStack, Ceph, and IPv6, although that's not open source, but it's a protocol. Anyway, let's get started because I'm trying to get a bit more in time. So, looking at KVM security groups in a shared advanced network, it is a hypervisor level firewalling of your virtual machine. So you can determine which packets are allowed inside your machine, going outside, so ingress and egress filtering. And you can have multiple instances sharing the same security group. And this is also a feature which is not used by many people, is that you can create a security group called database, which then opens the port 3306 for your SQL database. You can apply the security group to all the different virtual machines, and if you make a change to that security group, those policies are applied to all the virtual machines using the same security group. An awesome feature, but what I still see people doing, creating one security group per virtual machine, treating it as a firewall. And I would say use this more. If you're a service provider, I can understand that you might have a firewall per virtual machine which has different settings, but nowadays you can even attach multiple security groups to your virtual machine. So you can make a base security group which does some base filtering, and then per VM create an additional security group to get more granularity and filtering. Anyway, it's API driven and updates are applied live to any running instances. So if you do an API call, the management server gets crazy and starts doing stuff on all the hypervisors. And yeah, it's running inside the API as the image shows. In the UI, pretty simple. I create a security group here, an example security group. Port 22 is open for IPv4 and IPv6. And ICMP, everything is allowed, so you can send ICMP packets as you want to this virtual machine. So yes, it supports v4 and v6 natively in CloudStack for the last few years already, where you can have these security groups. But how? How do the security groups work? When you start a virtual machine, there's a startup command being sent to the agent, to the KVM agent, and that then executes the script securitygroup.py. It's a Python script on the hypervisor, and that starts doing some magic within the hypervisor itself. So, looking at the log file, it needs to be in debug. That's actually, you need to run CloudStack in debug always, because if you're not running on debug, you're almost blind how it works. So let's analyze what's happening here. This is a virtual machine which was being spawned on our clouds in Valencia yesterday, as you see, because I always make our presentations the day before. That's who doesn't, right? Who doesn't? So you see that there's a request coming in, a security groups rule command comes in, and user share CloudStack scripts, blah, blah, blah. Securitygroup.py is executed with the default network rules. It gets a few arguments like the IPv4 address, the IPv6 address of the VM, the MAC address, the interface, the local interface, the Linux network interface for the virtual machine, the bridge is going to be attached to, if it has secondary IPs, if it's a first network interface, etc. You see the arguments. Those are provided, and then afterwards it executes. So just within the same second, it executes the Python script again. And in this case, there's a rule saying that all ports for v4 and v6 are allowed to be open towards this virtual machine. Python script does this for you, and it's done by the KVM agent while booting the virtual machine. But what do they do? The default network rules. It creates an IP set for IPv4 and IPv6. Well, I guess that IP sets are known to everybody, which you can create with the IP sets where you can reference to within IP tables, or not known to people. Okay, then I'll continue with that. It creates EB tables for the MAC address, and it creates some basic security chains for IPv4 and IPv6, and basic security rules. I'll get to them in more detail. Anti-spoofing. Do we want a virtual machine to act as a DHCP server, a rogue DHCP server, and reply to DHCP requests? Well, we probably don't want to, so we're going to block those. And for v6, the equivalent, the virtual machine is not allowed to send out any router advertisements onto the network. Otherwise, you can hijack traffic. And this stuff happened, and I'll tell a bit about that a bit later. And then at network rules, it sets the ingress and the egress rules, TCP, UDP, ICMP, and the other protocols which are supported within CloudStack. So that's what it does. I looked at the hypervisor, ran the IP tables-save command, and looked at some rules which are coming on. It's pretty a long list. It wouldn't fit on one slide, so I just got a few lines out of there which are interesting. So at first we say any related and established packet, and remember this line, is going to be allowed towards the virtual machine. However, any packet leaving the virtual machine from the source port 67, which is a DHCP server, we're going to block them anyway. Regardless of the setting you set, it's got to be blocked by the hypervisor. Well, it also goes for if you're going to be sending out a packet outside, so any packet going in and any packet going out this interface, and it's not matching the IP set of the virtual machine, and the IP set contains the IPs, the IPv4 address in this case of the virtual machine, the packet is going to be dropped by the hypervisor. And here I highlighted the set as well, where we're referencing again to this set. So there's multiple lines where we reference back to the IP set, which contains the IP address. Same goes for EB tables. Any packet leaving the virtual machine should match the MAC address of the virtual machine, which we know which was assigned to the network interface. So MAC address spoofing is not allowed because EB tables does the filtering. It also does filtering on ARP replies coming out of it. So you cannot reply to an ARP saying, oh, this is me, you can send the packets to me. No, the hypervisor will block the traffic for you. So it's some hygiene, some sanity in your network which security groups do by default. Not only opening ports and closing ports, it does way more than just this. And I think some DNS traffic is allowed to flow through. IPv6, kind of the same, but also not really the same. Again, any related established packets are allowed in towards the virtual machine. But link local is something which is new, of course, with v6 compared to v4. So multicast traffic, some multicast traffic needs to be allowed. v6 doesn't work without certain multicast and ICMP traffic going in and out to the network. That needs to be allowed. So here we see that sending out a packet in and out, and it actually has a router advertisement coming outside the virtual machine. It's not allowed. We're going to be dropping that packet. You are not allowed to send out a packet advertising your router. Otherwise, a router solicitation, packet 135, is going to be allowed to leave the virtual machine and get in again, no matter what the settings you set. Otherwise, you will break connectivity of the VM. It's a long list of settings, but here we go again. We are matching to a different IP set with -6 as a suffix, which contains the IPv6 addresses of the virtual machine. So we know no IP spoofing is allowed in and out to VM. DHCP server, by the way, is the same here. We see 546. This is the multicast address, which is being used for DHCP and v6. All that kinds of traffic, it's a default. There's an RFC, by the way, for v6. I implemented this part in the security groups about 6-7 years ago. There's an RFC which says the basic firewalling principles for v6. I used that RFC to implement this stuff in CloudStack, so it is actually matching the RFCs which are out there. IP sets, pretty simple. One IP set contains its address for v4, and then the link local address and the unicast address for the virtual machine on v6 are allowed. Link local for v6, don't forget, it's a very important part. Blocking link local will just kill your v6 connectivity right away. However, if you do not firewall properly on v6, link local works. And not a lot of people know this, but this address is a functional address. If you think, I'll turn on my firewall and I'm going to be blocking everything on v4, but you forget your v6 firewall, if somebody is able to get into your layer 2 domain, so into a web server which is in the same layer 2 domain as a different database server, you can use link local to detect other nodes and just SSH to them. There's an RFC 2827, and this is best practice 38, which says you should do egress filtering of traffic leaving your network on the internet. Otherwise, your network might be participating in a DNS amplification attack. The amplification attack is pretty simple with UDP, because there's no sync and synchronization or acknowledgement being sent. You can spoof an address, send it to an open DNS resolver. So your query is 30 bytes. But the response is going to be sent to the victim, and the victim might get a reply of, let's say, 100 bytes or 500 bytes. So the amplification could be more than 10. So you just need to send address requests with spoofed UDP packets to public DNS resolvers. They are going to be replying to the source address, which was spoofed. And now you can send a massive, massive DDoS attack to this victim because your network, you were participating in it, your network was not filtering. So BCP 38 says you should make sure that every packet leaving your network was also destined or actually should originate from your network. Because routers, they never look at the source of a packet, they look at the destination. So a router takes an IP packet, looks at where it needs to go, it looks in its routing table and sends it to the next hop. The next hop will look at the destination, forward the packet. They never look at the source. So a router forwards based on destination, and it doesn't do any filtering based on source. If you implement security groups with CloudStack in your environment, you make sure that you actually apply to this RFC in the best practice, because it does the filtering for you. By the way, it says amplification factor 50x. True, I stole this packet from this picture from Google somewhere, so I forgot to actually add the source here. And the changes, pretty easy. You have the command authorize security group ingress or egress, one API command. But what does it do? A command is being sent to all the KVM agents which are applicable. So the only ones where a VM runs, which is using the security group, get the update, security group.py is executed again, and it changes the IP tables or IPv6 tables rules on the hypervisor, reflecting the changes you just made via the API. So it is simple, as Buzz Lightning says here. So as a summary, it's a combination of regular tools you'll find on a Linux system. IP tables, IPv6 tables, EB tables, IP sets, and it filters away certain traffic by default. So no IP and MAC spoofing, no rogue DHCP servers, and no illegal router advertisements leaving your network. And I said I want to go back to the IP spoofing. I've been working in the industry for 20 years now, and this story was about, I think, 8 or 9 years ago in our co-location network, which was a large shared layer 2 domain. Customers were complaining about performance issues, that they had packet loss, and we were trying to figure out what was going on. And after a few hours, we discovered that there was a virus on a Linux server where it was responding to ARP requests for the gateway. So the server started sending to the default gateway the packets to this rogue server in the network, and that server then forwarded the packet to our gateway again. So connectivity kept working, but by somebody being able to spoof the gateway, they were able to sniff traffic by just breaking into one machine on the network. So even though if you control your own server, you say, I don't need this because I'm going to be sure there's going to be no spoofing, somebody breaking into one of your virtual machines and then being able to hijack traffic which is going to your gateway, they might be able to sniff traffic for a very long time if they're able to do it properly. So it's not only a safety measure for BCP 38 that we are able to allow to send spoof packets, but it's also as a security measure just to make sure there's no rogue traffic or weird things happening inside your network. But performance-wise, because there's always a trade-off, it uses connection tracking on the host, NF contract. So think about that limit, because the connection tracking table, as I said, remember, related established, the hypervisor needs to be aware of all the connections going into the VM and out of the VM. Those connections are being tracked by the firewall. That will take memory out of the connection tracking limit. For certain applications, you might want to disable security groups if you want to do very high throughput of packets, because otherwise the connection tracking limit might become a problem. It requires a different network because security groups can be enabled and disabled per network basis. So you choose a different service offering for that network, which has security groups enabled or disabled. And then on the hypervisor, if the VM doesn't have any IP table rules, the packet never goes to the connection tracking table. So on the same hypervisor, you can have VMs which have security groups enabled or a network without security groups, and they will flow outside the connection tracking table. So you might see this, NF table full dropping packet. Who has never seen this message on a Linux machine, right? If you're something on the internet, you've seen this message before. So a DDoS attack can fill your connection tracking pretty quickly. Can we improve on this? I think we can. We're tracking all the packets right now going into a VM. I think that we can stop tracking certain packets going into the VM to alleviate the connection tracking table a bit, but I'm not really sure yet how to do so. But there's one thing I wanted to throw out into the community is that libvirt also has support for network filters and has been in there since version 1.0.8, which has been ages ago. We have our own Python script. However, within the XML of libvirt, you can define network filters, set all these policies, and then libvirt will do the heavy lifting for us. So maybe, it's an idea that we actually use the libvirt filters instead of our own Python scripting. We now have this Python script which is more than 10 years old. I think it needs some love. It got some love in the last 10 years as well to make it better, but it might be that the libvirt network filter is something we should be looking into to improve. So maybe some opinions, ideas about this, I'm not sure, but looking at the supported protocols and looking at the documentation, I looked at this a few years ago, I looked at it again this week and said, well, I think this is a possibility as well. So this might be a future enhancement just to get rid of some old code and just leverage libvirt for this. And that was mainly it. Just a quick look on how the security groups work under the hood with KVM. Any questions online or?
There was one online, but we'll take the room first. Hi, Sven.
What kind of networks can you use for that type of firewalling?
The shared network. It works in basic networking. It works in advanced networking with shared. So when there's no virtual router between the VM and the actual gateway. So shared networks.
Any more questions from the room?
I have two questions. First, is the protocol number supported in the security group rules? I don't remember it.
The protocol number?
Yeah.
Yes. This was a PR from you, actually, a few years ago. Yeah, it is supported. Yeah, it is supported. Okay, so that's why I said in this slide, I said TCP, UDP, and ICMP, and other protocols, because it was a PR, or you reviewed it, but you can set in your own protocol number, so GRE and such, and IPsec are supported to go into the VM.
Okay.
Yeah.
Yeah, thank you. Second, I have another question. Do you have virtual machines with multiple interfaces, and have you ever research on the security?
Yeah, so we have VMs with multiple interfaces. There is one, I wouldn't say security thing, but we create one IP set per VM. So the IP addresses of the VM, all the IP addresses go into one IP set, but the network, the IP table rules are being set per interface. So this is VNet 4, but let's say VNet 5 is a secondary network interface. Our source address filtering is done on global level per VM. So you can send out a packet over VNet 4 for an address which should be connected to VNet 5. That is a slight improvement we can make there. Yeah.
Does it make sense to create one rule for this according to the best practices guide? So it's easier for the CloudStack admin to just include it, apply it to the security group.
The default security group within CloudStack blocks all traffic. So that's something with new users. I've sometimes helped them through. They said, my VM isn't working. No, you need to open ICMP, SSH. I think security-wise, that's good. If you enable security groups, it does all the filtering. I think security groups are enabled by default in CloudStack if you create a network, the service offering chosen. But I just wanted to show that what it does more than just opening and closing ports. So if you would have a security group like this, or make this start port -1, -1, -1. You open all ports to the VM, but the filtering for BCP38 still happens on the hypervisor level. So yeah, open all the ports, but use security groups because they provide an essential feature for filtering on the network. Yeah.
Thanks.
Thank you. So a question from the online audience. Is there a check in the API to check if securitygroup.py isn't compromised before applying the rules?
No, there's no API, so check for that. No, securitygroup.py, yeah, theoretically it could be compromised, but I think that the compromisation of that file should be on a different level than the API itself. That should be operating system detecting changes to that file.
Sure. Thank you, Wido. Any more questions for Wido in the room? Fabulous. Thank you, Wido.
Okay, welcome.